This lesson will cover properties of quadratic functions in standard form. This is lesson 5-2. So before we get down into it, I wanted to go over some basic concepts here. What if we wanted to graph a function like y is equal to 4? Y is equal to 4 is going to be a horizontal line that goes through the y-axis at 4 units up, so right here. So I'm going to do my best attempt to draw a horizontal line right through there, and I've succeeded, sort of. Now let's graph y, or x is equal to negative 4. Now when we're going x equals equal to negative 4, you don't see any y or anything else. You're going to go and draw a vertical line that crosses the x-axis at 4, or negative 4. So this is just a refresher of those concepts. Y equal 4 is actually can be considered a function because it'll pass the vertical line test, whereas x equals negative 4 cannot. But x equals negative 4 is what we're going to bring back up in a few minutes here. So when you see something where it says x is equal to and it's a number, you're going to find it more important later on when we talk about symmetries. So let's take a look at something here of a problem that says, another recall, find the vertex of f of x is equal to 3 times the quantity x plus 2 closed quantity squared minus 5. So if I want to find the vertex here, well, it's actually pretty straightforward. I need to look here, check the sign, and then I need to look here. This is for h and this is for k. Now if you remember, it's always x minus a number, and in this case it would have to be x minus a negative 2. So really the h value is the negative 2. So that's the important thing to remember here, is it's not the positive 2, it's always x minus an h value. So in this case the h is negative 2. And the k is pretty straightforward. It's whatever you see on the outside of the parentheses that's not multiplying the parentheses. So in this case k is negative 5. Now the vertex is always written as h comma k. In this case it would be negative 2 comma negative 5. Pretty straightforward with this form of the equation, considering that this is called the vertex form. But let's take a look at some new stuff. So that's the review, getting you prepped for this. So new stuff, find the vertex of the function f of x is equal to 3 times the x squared minus 12x plus 15. Well, here we have a different form of a parabola. This is still going to graph as a parabola, but it's not written in vertex form. So we need to know a couple things about this new form in order to work with it. So let's step back and talk about it. So the first thing you need to know is what the standard form is. Standard form is another way of writing parabola equations, and is the more common way that they'll be written, to be quite honest. It would be nice if they all could be written in vertex form because you can spot the vertex just by looking at it. But unfortunately that's not the case most of the time. So the thing we need to remember about a vertex is it's a point. X comma y, some x and some y, and I'm not going to be able to pull that from this generalized form right here. I don't know what it is. Let's talk about how we find the vertex now. You'll see that we have an A, a B, and a C. The A and the B are coefficients, and we've talked about this before, and it's possible that you've forgotten. Coefficients are numbers in front of a variable. Any number that's multiplying that variable. C is going to be what we call a constant. A constant is basically any number. The antithesis, I guess, if you want to call it that, the antithesis is the variable which can change at all times, and that's the x values here. So these are the variables. And it's really the same variable, and you plug in different numbers, and in this case you would square it, and then you only just take that number and multiply it by whatever b is. But the coefficients and the constant really control the shape of the graph. We already know that, the placement of the graph. The x squared controls the shape. We know since it's squared, it's going to be a parabola, and with the a, b, and c, it moves it up, down, left, right, and all those things that we did with the vertex form. Unfortunately, it's not as easy to spot or do. Typically when you have an equation in this form, you're going to create a table or use some other things that we're going to show you right now, including the y-intercept, some symmetry concepts, and the vertex. the vertex is still important. So how do we find this x comma y vertex thing, which we were used to calling h comma k, but that only worked when you had that form of the equation. So now the way you find the vertex is you take the b coefficient right here, you make it negative, so you go negative b over 2a. That number will give you, whenever you calculate there, will give you the x coordinate of the vertex. You plug that number back into the equation as I've indicated here, f of negative b over 2a, and you get the y coordinate. So in other words, whatever number you get here, you plug it back into the equation and you find the y value of the coordinate, and that gives you the vertex. So, simple enough. Use this formula, then plug the number back in and get the next one. How do we do that? Well, let's take a look back at this equation. Again, this is the same equation that I wrote right up here, but now we're actually going to do something about it. So let's use the vertex formula that we have here. And by the way, this is something you definitely want to memorize. And let's find the x. Now, before we can do that, I think a key thing to do is state what a, b, and c are. And since this is new, it might be difficult for you to see. So what I'm going to do right above the equation here is I'm going to write the standard form, the generalized standard form, because this is written in standard form. And what I mean by generalized is using a instead of a number 3 or whatever number you want to use, b instead of a number, and c instead of the constant. So let's see. A in this case looks like it's 3, so a is equal to 3. B looks like it's equal to not 12 but negative 12, and c is 15. So once we have those things identified, what we can do now is just plug them in for our a's and our b's. So now we've got negative b, which now is going to be negative 12 over 2 times a, or 2 times 3. And I'll put it in parentheses because it's the same thing as multiplying it. So let's see, negative b is really like saying positive. So negative 12 is positive 12, and 2 times 3 is 6. We simplify this, we get 2 over 1, or just 2. So now we have the x coordinate of the vertex. So as I'm writing the vertex here, I can write in the 2, comma, and we're waiting for the y. So I'll put a question mark there. How do we find the y? Great question. Well, look up here and it says plug that number back in for the equation. So the equation is f of x is equal to 3x squared minus 12x plus 15, and then I state what I'm going to plug in, which is x equals 2. So I plug that in and I get f of 2, everywhere I see an x basically I plug in a 2, is equal to 3 times 2 squared. And I like to put, anytime I plug a number in for a variable, I like to put that number in parentheses. It just helps make things simpler, and we're still multiplying. That's what that's really indicating. So now I've plugged it in and I've just got to simplify it. And I will be honest with you, I'm going to use a calculator for this because it just makes things so much simpler. So let's plug stuff in here. So now we've got 3 parenthesis 2 close parenthesis squared minus 12 times open parenthesis 2 close parenthesis plus 15. So as long as I've written that correctly, I should get the correct value out. So f of 2 is equal to 3. So what you may have noticed there is I didn't make you show you all your work on this. We're now beyond the point where I'd like to see you evaluating these ones on a regular basis. Only occasionally will I tell you to do it by hand. But what I will look for is the following, and I'll highlight it. You write the equation and you tell me what you're going to plug in. You show me how you're going to plug it in. So you write it out so that when you go to put it in a calculator, you know what you've got and you don't make any mistakes that way. And then you state your answer. So now that I've done that, I know the y value of the vertex. So now I can plug that back in over here. So now I have the vertex at 2, 3. We can check that now. How do I check that? Well, I'll go into my graphing calculator, and I've turned off the equation I have up there because we'll use it later on. And I'm going to plug in the equation that we have, which is 3x squared minus 12x plus 15, and I'm looking to see if the vertex actually shows up at, oh, I can't see it right now, 2, 3, right over here. So the best thing to do though is before I do anything is hit zoom and then hit 6, which is zoom standard. So it looks like it does indeed have the vertex at 2, 3. So there you have it. If you want to find the vertex of an equation written in standard form, which is a new thing for us, this f of x is equal to ax squared plus bx plus c, you need to identify the a, b, and c, plug it into the formula, and then just solve. So a couple new things again here. The standard formula, you need to have that memorized. How to find the vertex using the standard formula, these two equations right here, and then just the procedures to do it. So now that we've done that, we're going to start getting into some nitty-gritty here and things called the axis of symmetry.